Hello, we're back, and today we are going to talk about predictive maintenance in industrial settings and how far we have come with the project AccuTrack, our SCADA system, and what we want to achieve. So we go back to our project from where we left it, and we can see we made some improvements from our last iteration. And this time we have focused on making the screen more viable, the components that are working, we have the uh, indicators properly working. And as you can see, this indicator is indicator for joint 2. This joint 3 indicator, as you can see from here. We have the above, and our buttons are working just as normally as it will happen in any SCADA system and HMI system. We have our buttons. So the goal here is to make machine learning available to each and every category of engineer, and they can be able to train and configure models. So we are going to look at how it's running for starters. So we first we rebuild our project, and we are going to start our runtime, and you're going to select the actual project that you want to run. And here is our project. So for us to run this in a manner that you can see, if we start, if we jog, if we stop, if we reset, nothing happens. However, we can see that there is a script that is running that has shut down everything when we click on reset. So that script is located here. In the scripts, we have the ML post-processing script, and we have the robot control script. So these scripts are written in Lua, the scripting language Lua. So we go back to our runtime, and we realize we don't have a robot running. So we have our robot controller. It's here. So we have the main file that runs two functional codes. So we have the Darkstar command. So this basically does the basic buttons. When we click on start, stop, jog, and reset, those are taken care of by this. And then the physics, this is what runs now the simulation data, tries for each joint, tries to randomize the data that we process for each joint. So it's now we go back to this and we see it's around our controller. So we can start our controller, and of course it's our Jackals of FPLC. So this script is scripted text that's running on the controller, so but it's not what will be running in an actual controller. So our controller has started, it's just a simulated PLC. And now we go back to our runtime, and as we can see, our runtime has connected to our controller. So we can start our runtime, and we have our first joint, we have our second joint, we have our third joint running, fourth, um, fifth, and the sixth joint. So you might realize that the hours might change depending on what what is the value of the torque that we have, what is the value of current, voltage. So voltage tends to remain constant most of the time because it's around 47 volts. The current ranges from 1 ampere to 3 amperes. The torque can change depending on each joint, the randomization value of each joint. So these will give you different hours, remaining usable life hours for different joints. So the goal here is to show that these how do we train our models? Is it possible to train our models in our designer? So let's close this and we'll come back to our model. So we can close this. And here, these are the models that we have. Okay. So currently our model is designed to run only CPU models, but this is RKNN. It's for our HMI, physical HMI device. So we go to training. Let's do training for a single model. So we do model selection and we have remaining usable life, category all. It's just one model that we have in our category. And we have this. So we go to model configuration. We currently do not have any model configuration. We go to parameters, and here we can select the training CSV data, that is motor test data, CSV. It's a small file. We go and select the training script. That's our training script. We need a requirements file. And then we have the out directory. It will save to this location, AccuTrack models, and the trained model file, no extension required. So this is RL, but let's name this RL retrained. Okay. So no template, but we can save this template as a training template. And we can save. Okay. Now, um, leave blank. So we will leave this blank and output directory. It will be taken the same as this. Okay. So we go to input configuration. So this is taken from the data from the model. The first thing is the voltage. The second is the current, the temperature, and the torque. So the data source, this is the CSV file. This is what the model shows, uh, requires the values that the model exposes. We will not have anything for RUL hours because we are training for RUL hours, and we go to training. Now, we leave this as it is, and the output directory will also be taken from the training model configurations that we had here in the parameters. So we have to do training and then we run training. So our model has finished training. Now we need to convert this to first it has produced this file. Just a second. Browse this. Open. Yeah. It has produced RUL this, and if we need to convert, we'll convert to this. So as usual, we'll do a few tests. The first test is we'll test for WSL, and we'll see if a WSL is available. Yes, it's available under this IP address. We test if we have the RKNN toolkit installed. Yes, it is. And then we just click on convert. And conversion takes place successfully. And we can now see that we have our RKNN file. So yes, our RKNN file is available. So our RKNN RUL retrained RKNN file is available. So we can do validation. We cannot validate RKNN files. We want to validate .onnx file. So we go to documents, track models. This is our output file. And we are validating this. Now we do a validation. We want to validate if our model has trained correctly. So voltage, we give it 46. Current, we give it at 2.3 amperes. Temperature, let's give it at 6 degrees Celsius. And a torque of 10 Newton meters. And we run prediction. So it's giving us this period of time in us. Now let's try again. 43, current 1, temperature 10, and torque 15. So the values that we are getting here, they're not the best per se, because we expect our these values to, like these sensor values, to make our product less. It's not that much. It is not experiencing a lot of strain and stress. So we need to recheck this. But this will take place in training. How do we train our models? If we have the data, we have if you have clean data, we have the model, we can easily train on that data, retrain, and deploy the model. Because when we click on download, it will download the actual model that we have configured on our machine learning. So these models, they will each be deployed together with the entire project. Yeah. The next time we're going to see AccuTrack as a web application, and we are going to try and see if we can develop projects based on such web implementations, not just desktop implementations, but implementations for web applications.